Hi everyone, I'm Madhumita, product lead at StarTree. I'm very excited to be here along with Suvodeep, who is my colleague. We are going to give the talk on troubleshooting real-time business metrics. It's a very favorite topic for me. And without further ado, I would like to get started. I always start with a quote. So today's favorite quote for me is real-time business metrics are constantly changing. That's why it's very important to be proactive in detecting those issues. Don't wait for a problem to become a crisis before you take action. So that's the crux of today's talk, and something very close to my heart, and I have experienced it and been living through this for some time. And today I'm very excited to share my journey, my story, along with my colleague Suvodeep with all of you. So, what are we going to talk about? Some of the challenges and introducing to real time metrics monitoring and anomaly detection. That's what I will be covering, and then I'll hand it over to my colleague who will give a walkthrough of real life use case and how to troubleshoot that, a live demonstration of that, and then he will touch base on some of the benefits and advantages, and we will open up the floor for Q&A. So stay tuned, you're going to learn a lot and a lot of interesting stuff we are going to share with you in a few minutes. So to start with, what are the challenges associated when it comes to troubleshooting real-time business metrics? Real-time business metrics are the metrics that you're monitoring to identify any issues that are happening in real time. So one example is in IoT space, if you have several devices planted across different locations and those devices are getting heated up, and you would like to know as soon as possible before it becomes a crisis, which means the device shuts down or something like that. And that's not good for your business or not good for your users. So in net is very, very important to monitor that, but something goes wrong, then troubleshoot as quickly as possible so that you can take action. So now to do that, what are the challenges involved? Well, when we talk about metrics and that too in real time, data is something stands out. In the era of generative AI, data is everywhere, and the data volume and velocity is becoming very, very important. So handling massive amount of data in real time, what you need, an efficient storage solution and processing solutions. There are not many out there. So that's a challenge. Now, second thing is, if you're troubleshooting, then you're making decisions around what are you going to do next, whether you have to fix the device or something else going on to fix that. Now, to do that efficiently, you need to have good quality data. You need to have consistent data. Otherwise, you're not going to be making qualitative decisions in real time. And that's going to be a big challenge. Now, what's next? Well, data quality we talked about, data we talked about. Now, data is everywhere, as I was saying, and especially if you're talking about IoT world, data is in multiple devices, data is internet, data is offline. You're integrating all that data to make a sense out of it in real time. That's very complex, and that could be also hindrance if you're not doing that on time and accurately. So that's another important aspect you need to consider. And latency and scalability is another big problem. Like if you are also trying to solve through a solution, latency becomes a challenge. There may not be data may not be arriving on time, or you're not processing on time. There are multiple issues involved, and now as data is growing, you can't scale it either. So these are some of the limiting things to do troubleshooting in real time in a smart and efficient way. So now, what's the solution? Well, since we are talking about metrics, we will have to monitor the metrics obviously, but monitoring is just not enough. You need to identify those anomalous events as quickly as possible, because it's very, very important. And the sooner you detect, the impact is going to be high in terms of revenue or cost savings. Now, what is this anomalous events? These could be spike or drops, or could be gradual change over a period of time, which is very, very hard to detect in a manual way. And just detecting anomaly events are not enough. You need to have the cause, what is causing this anomalous event, so that you can troubleshoot as quickly as possible in real time, getting answers and then taking actions. So these are actionable insights, which is very critical for a qualitative decision, which is hugely associated with cost implications. So in general, the solution to troubleshooting real-time business metrics is having a metrics monitoring system and detecting anomalies and identifying those actionable insights so you can make qualitative decisions as quickly as possible. Now, what are the different scenarios of this anomalous event? So the different scenarios are, before we talk about the scenarios, let's talk about how would you build a solution like that, right? So the first thing is you're bringing in all this data, storing it in an efficient storage, making a meaning out of it, then identifying those anomalies by applying some algorithms, and then determining those insights by looking at the data and then providing the insights. So stitching it all together provides a automated anomaly detection solution. And in addition, that is not enough, because we were talking about metrics. Metrics can take any shape and form. It could be steady, it could be upward trending, it could be seasonal. So detecting anomalous events through this different various pattern of data in real time with a solution that I spoke in my previous slide, stitching it all together is not easy. And on top of it, detecting accurate outliers is also not easy. Applying a lot of smart algorithms is not easy, because you need to write the algorithm, apply the algorithm, or if you are using out of box algorithm through libraries, but you still have to stitch it together, apply it in real time, and then detect those accurate anomalies based on your business context. Combining it all together, it's a huge challenge. Now, is there a solution out there? Well, of course, and which is what we will be giving a live demo of that will help you to understand how you can troubleshoot in real time. So the solution is StarTree ThirdEye. It helps with real-time metrics monitoring, almost near real time, and anomaly detection of large and complex time series data. And it fast track problem solving by unlocking those actionable insights that I was talking about. Now it has 3 core pillars, where you're stitching the data real time and offline, and storing in a very efficient storage and computing resource, which like Apache Pinot. ThirdEye is built on Apache Pinot, which is a columnar data store and does an OLAP and allows you to run massive queries in your data in a very compute efficient way, and gives you results in fractions of seconds. So you can apply your smart algorithms in an automated fashion, detect those outliers as quickly as possible, in the accurate outliers, and providing an interactive UI and getting those actionable insights throwing at you to make a quicker investigation to get to the root cause and then make some informed and qualitative decisions. Now, this solution is very awesome. It's something my favorite. It also has a smart UI, low code, no code UI, and also API based solution. So with that, I will hand over to my colleague, who is going to give a live demo of some of the real life use cases and how you will use this tool to troubleshoot in real time and be self-efficient on your own. And something very interesting you don't want to miss out. So stay tuned for the next half, And welcome, Suvodeep, and handing it over to you to give a walkthrough of the exciting use cases you have in the live demonstration. So with that, looking forward to my next segment of the talk. Thanks.
Thanks, Madhumita, for the intro. Hey everyone, my name is Suvodeep. I'm a founding engineer at StarTree. I'm going to walk you through a couple of use cases around anomaly detection and also show you under the hood how ThirdEye works and how are we trying to tackle some of these issues. So for the purposes of this demo, I'll share the rideshare use case that we have, as well as some IoT use case, which we have in terms of data around sensors. And yeah, let's jump in. So here we have an instance of ThirdEye, which is a demo instance. This is how the dashboard looks like. It gives you an overview of what's happening around your system. Are there any anomalies? What are your charts looking like? How are your metrics behaving, etc. So let me quickly jump into the create alert. So I'll click here, and I'll just try to show how a ThirdEye simple alert works and what does it to create such an alert. So let me just go ahead and create a basic alert here. I'm going to use the rideshare dataset, and let me just choose wait time. So just to explain the context here, so we have Pyne, which is a time series database, which is showing all of these datasets, and we're choosing a metric here, which is in this case wait time. So rideshare is typically, think of it like a data set for Uber, where you have these cab rides which are being taken all over the place, and we're trying to monitor different metrics around them and trying to figure out if there are anomalies associated with it. So I'm going to go ahead and load the chart. So notice that the granularity is daily, meaning that we are trying to aggregate daily wait times over this period of time. And in this case, I'm aggregating with sum. So I'm adding up all the wait times and showing it on a per day basis. Now the metric looks reasonably well behaved, except probably this weird spike here. And maybe I'll just change the granularity to hourly to see how that looks like. As you can see, the metric is fairly seasonal, except this particular spike. So I'm going to actually try to create an alert on top of this, so that if we see such kind of spikes, we want to know, make sure that the system is actually behaving okay. So ThirdEye actually shows you a whole suite of algorithms. In this case, these algorithms are helping you to detect anomalies. I'm going to actually go ahead and choose the matrix profile in this case, which is a StarTree algorithm that helps you with patch level analysis and figure out anomalies for use cases, especially like this. So let me go ahead and select that and click next. So I'm not going to change any settings. I'm just going to just load the chart. And as you can see with the default setting here, I'm able to actually see that the algorithm correctly predicts that there is a weird spike here, which is very different from the overall metric. So I'm actually pretty happy with this. I'm going to go ahead and click next. So I'm going to skip over all of this and go ahead and create the alert. Now what happens is that we just created a basic alert on a metric, and ThirdEye in the background is actually running a task which goes ahead and checks for, or rather performs the entire detection routine on these metrics, and eventually comes up with its results. In this case, as you can see, it took a few seconds, and then it showed that, hey, this is the anomaly that we have. So this is roughly the workflow of ThirdEye. And ThirdEye not only does a basic level of alerting, but it also is really good at multidimensional alerting. So let me show you an example of what I mean by that. So I'm going to go back to the home page and go ahead and create alert. And I'm going to just go ahead and show you what a multidimensional alert means here. So imagine that you have this rideshare metric and we were doing sum over wait time. And what if I wanted to know that I want to know the wait times across different cities or different ride types, So in this case, I'm going to let me go ahead and choose a data set here, and I'm going to just choose wait time as the same metric. But in this case, I have a bunch of dimensions. So I can choose on city, I can choose on driver rating, maybe device type. Ride type also looks interesting. So in this case, let me just go ahead and choose that. So I see that across ride types. So what is the distribution here in terms of the amount of wait time across these different dimensions. So in this case, I have right track is shared, premium, economy, and they have more or less similar wait times across this entire time period, right? And that the reason is because in this case we are using a simulated data set, but with real data you'll see a lot more color here, and it really talk about which dimensions or which combinations of dimensions could be important. Actually, I can actually go ahead and choose city and right type here. So ThirdEye will actually go ahead and run combinations of these metrics, these dimensions, and then try to figure out, hey, which particular fraction of your data has a larger impact to your overall metric. So in this case, as you can see, folks are waiting a lot more in New York versus the other slices of data. In this case, San Francisco and economy is probably just 16% of the overall traffic. So in the interest of time, I'm actually go ahead and for example, in this case, I can just go ahead and select all of them and say create multidimensional alert. So what ThirdEye will do is actually go ahead and create an alert going through all of these different time series and monitoring them in one single alert. So that really helps you have an overview over different slices of the metric, all of them in one single alert, which is extremely powerful. So I can just go ahead in the usual process and go ahead and create the alert here. For the purpose of this demo, I actually have an alert created. So let me just quickly go ahead and jump on that. Cool. Oh, I see. That's the dimensionality is slightly different here. But let me walk you through what the analysis of an anomaly looks like in ThirdEye. So ThirdEye not only helps you figure out what is an anomaly, it also figures out, or rather helps you in figuring out what could have caused this particular anomaly. So in this case, what I see is we have right type is equal to economy, and I can actually go ahead and expand that chart. And I can see that, okay, the algorithm is actually pointing to a couple of cases where these spikes are not favorable. So I can actually go ahead and see what these anomalies mean or why they're anomalies. So if I click on this particular red dot, it actually jumps to the anomaly right away. And I see that there is this big spike here, which is kind of a little bit odd compared to the metrics surrounding it. So maybe it is an anomaly. I have to investigate and figure out. So what I can do is I can go ahead and click investigate, and this will give me a much deeper view into the underlying metric and how ThirdEye is able to analyze all of that and present it to you in one phase. So this is what the root cause analysis module of ThirdEye. So in this case, what you can see is the algorithms in ThirdEye root cause analysis is trying to analyze the underlying data and share with you what could have caused this anomaly. So there are a few results here, and the common theme, if you see here, is that maybe the traffic condition here was heavy or moderate, or we don't know what exactly, but in this case seems like that seems to be coming out a lot. The other thing that ThirdEye does is offers you different kinds of tools. In this case, heat map is one such tool, which gives you a lot of ability to figure out which dimensions were behaving weirdly. Like in this case, anything that's blue increased and anything that's red decreased. Now, since the RCA, the top contributor, suggested that the traffic condition could have been one of the reasons, we can actually see that from here in the heat map that moderate actually increased quite a bit in terms of traffic. So we see that this entire change is 161% increase in traffic moderate, and also some sort of an increase in heavy as well, which is in this case tripled. And actually light traffic is pretty small. So maybe it could have been that in this particular time frame, the traffic was actually pretty heavy, and that was probably the reason why there were issues in the wait time. So we can actually add some of these things into the chart and see how they behave. So in this case, I'm going to go ahead and search traffic equal to heavy, and just go ahead and click that. When I do click this, you can see that there is this underlying chart which actually goes ahead and shows me that what percentage of this metric was actually contributed by the heavy traffic. I can do this similar for moderate traffic as well. So in this case, I think I'm adding both. So I'm going to go ahead and add this to the investigation. So as you can see here, it seems that pretty much a decent spike is coming because of traffic condition equal to moderate. And that might as well be one of the reasons why we might be seeing some of these spikes in wait times. I'm going to go ahead and go to the next step. So ThirdEye also gives you an event framework to work with. So the whole point of RCA here is to basically take take an anomaly and translate it to an event that can cause this anomaly, right? So in this case, if you had a spike in wait time, what event could have caused this anomaly? And ThirdEye tries to put a lot of these information in front of you so that you can kind of make an informed decision here. In this case, we have a whole bunch of events which are just holidays coming in from different areas. So I'm going to actually go ahead and select all of that, and you can see that ThirdEye is trying to find related events in the around the time period that the anomaly had occurred, and kind of tries to plot them across time. So in this case, if I see there was an Armed Forces Day, for example, which could have been one of the reasons why there was traffic maybe in San Francisco. But this is how ThirdEye would kind of try to correlate different things together and put them in one place so that you can make an informed decision. I'm actually going to go ahead and click next, and then you see that I can have this space where I can save the investigation. So in this case, I'll say traffic was traffic heavy or moderate was the reason for the increase in wait time, right? And I can go ahead and save this investigation. And this now is a shareable entity that you can share with the team or with other analysts who might be interested in knowing what's actually going on or what your analysis was and why did you get to that, right? So this is broadly the workflow in terms of the overall anomaly detection to RCA, right? So let me just quickly go through another use case which is more related to sensor data. So in this case, I have an alert which is just doing temperature analysis. Maybe not this one. Give me 1 second. Oh, probably it is this one. All right. So yeah, in this case, we can actually go ahead and see that, for different devices. So this is not a temperature monitoring of this is not again an overall so this is not again an alert which is working on the overall temperature, but rather on the temperatures of each device IDs, right? And which is very interesting because you can have a much deeper insight into every device that is working in this case. So why was the temperature of this particular device much higher than usual, right? And this is, again, we can basically go ahead to the same flow that we did earlier, and we can get an insight as to why or which dimensions are actually maybe having an impact. So in this case, we see a much fewer set of dimensions compared to our previous ride-share use case. But as you can see here, it seems like simply because a lot of devices started becoming more active. So maybe in this case, that's probably one of the reasons why maybe the overall temperature went up. In this case, I think the alert was set on a sum of temperatures. So I assume that probably that it might be a reason. So in short, what ThirdEye is trying to do here is, if you have a set of metrics and you have a set of dimensions associated with it, ThirdEye can really do a deep drill down and try to find all sorts of correlations and causations around it, so that you can make an informed decision as to what your anomalies can be related to, or what are the correlated events, etc., that can be reason for that particular incident. So yeah, that's all I had in terms of the demo. Let me just share a few things now in terms of how ThirdEye works under the hood. So yeah, I want to really touch upon some of these concepts just to illustrate that everything is not like there is some work under the hood that needs to be done in order to make sure that your data set is performant and the anomaly detection goes smoothly. So the way ThirdEye does all of these analysis is, ThirdEye is actually pretty noisy in terms of querying and figuring out, hey, every minute, every 5 minutes, depending on what level or what speed of responsiveness you need from ThirdEye in terms of getting that current value of the metric, and this can be expensive. So it's very important that the data is actually modeled right. So some of the things that I would like to call out here is this is where actually Apache Pinot really shines, because it is a database designed for time series. It really helps us make sure that we are able to give timely responses to the user in terms of some of these queries which are constantly monitoring your critical metrics. Also, one of the things that is important is how your data is organized in Apache Pinot or any kind of these databases, because how your schema is set up, how your data is set up is immensely important in terms of getting your results performant. So for example, I just picked up a couple of use cases here. So in this case, if you have your timestamp as a string, for example, these are typically much more expensive in terms of compute power to parse rather than if you have something like a long, right? And it's keeping these factors into consideration when you're modeling your data that really adds up in terms of making sure that your monitoring system is performant and is able to live up to the requirements that your analysts are providing. Another thing that you might be thinking is that, okay, time buckets is an interesting use case as well. So the idea here is that whenever you want to bucket time, so let's say you want to round it off to the nearest minute, 5 minutes, hour, 15 minutes, or daily, there is a lot of translation that happens in queries. And sometimes when you're monitoring a high throughput query, it kind of gets difficult in terms of aggregating all of these into runtime and can add up into costs at runtime as well. So making sure that you have the right derived columns or making sure that your data types are set right is actually crucial in terms of making sure that your alerts are performant. Lastly, I also add that certain kinds of systems are capable of handling like aggregations in a much more faster and more efficient way. The whole point here is to be able to avoid expensive query scans, table scans. And StarTree Index is one such example. What StarTree Index does is it's able to, given a configuration, it's able to pre-compute a lot of these metrics under the hood and keep it prepared so that if you're asking for a certain set of queries, it's not a table scan anymore. It's just has all of these things pre-computed and gives you a number right up front. And this is extremely powerful in terms of whenever you're doing a large number of dimensions across a high cardinality data set. And also whenever if you have like a lot of rows getting ingested every minute, this becomes super important so that you don't you're not reading a lot of data. So yeah, coming to again, this is how we're kind of positioning ourselves in as well, because ThirdEye is something which has a high query volume and it requires low latency, because we want to make sure that we are responsive to the user in terms of reporting anomalies. We actually pair up really well with Pinot, which is a real-time time series database, and it really is capable of handling these aggregations, and it has a lot of indexing capabilities that ThirdEye is able to leverage and make sure that we are able to stay performant across the entire vertical. Another thing that we also make a lot of use of is Pinot's ability to slice across different dimensions with things like StarTree Index, and ThirdEye also builds on top of that capability to make sure that we just don't monitor things on an overall level, but we were able to slice much deeper and give you insights much more quicker in terms of being able to drill down and look at exactly the right dimensions and their slices in this case. All right, so let me talk a little bit about what the detection looks like in terms of how we're detecting such anomalies. So ThirdEye actually has a very sophisticated anomaly detection flow, and this is what we use to kind of model alerts. So the same flow that you're seeing that we are modeling a single metric is the same architecture that we are using to model multiple dimensions as well. And this kind of capability gives us a lot of benefit in terms of being able to model derived metrics, being able to do runtime computations, and make sure that we are exactly we are able to monitor a diverse set of use cases to kind of give you the results that you need without doing a lot of pre-computation. So ThirdEye actually is capable of handling a lot of these flexibility on its own. We do have a solid notification framework. So currently we support email, Slack, and PagerDuty is coming soon. The main goal here is that once your anomalies are detected, we want to make sure that we are able to present it to you in a way that's consumable to you. And notifications is exactly designed for that. So we have like a very solid notifications flow, which makes sure that we're able to consolidate all the report properly and kind of feed it to you in whatever way. You can also build your own integrations with webhooks, but this framework actually prepares and sends all of these reports to you live in real time. All right, so ThirdEye is obviously API first. We pretty much do this pretty much for everything at StarTree, and the idea here is to be able to build applications on top seamlessly, and this kind of gives you a lot of scope in doing that. So pretty much everything that we have showed you on the UI is very easily integratable by some API provided by ThirdEye. We are cloud ready as well. You can deploy us in Kubernetes. We have a Helm chart. And we are available at GitHub. So we have a community edition, and that is available at github.com/startreedata/thirdeye. And feel free to try this out and let us know your feedback. Most of the tools that we have shared here is available in the community edition. Sure, there should be no problem in kind of reproducing this. And that's pretty much it. So here are the links as well. Feel free to try out join the StarTree community or try out the community edition. If you guys want to be a little more hands-off and want things to be more, delivered to you in terms of a whole package, the enterprise version is also available for you to play with. You can go ahead and use this self-serve trial. With that, I will wrap up. Thank you so much and happy holidays.